Hey everyone, it's Mr. Wolfe here, and in this video I'm going to be going over problem number 2, parts A and B on page 10. So let's take a look. This is going to be a little bit different than our other hang time problems that we went over in class or I went over in the video. And so the question is, Mr. Wolfe goes real hard on a layup and is in the air for 0.97 seconds. So the teacher who made this gave me a very generous hang time. So how high did I jump? So this is a little bit different. Normally I give you how high the person jumped and you have to figure out the hang time, but now it's the opposite. So how do we go about doing this? My recommendation first is I always like to draw a graph, a y versus t, position versus time graph of the situation. This one's a little bit small because I'm not given a lot of room. And then I could always reference that later when I need to. So I'm going to look at some of my givens in this case. And so, well, I guess before I do my givens, I'm going to go back to the graph and let's try to choose. We can't solve for the whole, like this whole problem right here. We can only solve for one type of motion at a time. And that'll actually make sense when we're looking for our change in distance, our height right here in terms of how high Mr. Wolfe jumped. So I always like trying the time down first. So on this graph, I'm just going to kind of draw a line here that says like time down. And that way I know that when I'm solving this problem, I'm just solving for this part. So if that's the case, if I'm solving for the time down, now I know some givens. I know that the apex, my initial velocity, just as I'm starting my descent, is going to be 0 meters per second. The acceleration due to gravity is always negative 9.8 meters per second. And in this case, I know my time down. And a big mistake would be just put in 0.97 seconds because you see it on the piece of paper, but that 0.97 seconds is not the time down, right? That's the total time. So that 0.97 seconds is the total hang time. So how do I figure out my time down? Well, if we go back to the target sheet, it turns out that the time up is equal to the time down. So all I need to do to figure out my time down is just divide it by 2. So 0.97 divided by 2 is going to be 0.485. So my time down is 0.485 seconds because it's half of my hang time. And that's really, really, really important. Okay. So the equation I'm going to use here, if I have my time, my acceleration due to gravity, and my initial velocity, and I'm looking for how high I'm jumping, well, there's only one equation for changing motion that has my change in position, my distance, and that's going to be delta x is equal to 1/2 at squared plus my initial velocity times time. So now I just need to substitute. I'm looking for that change in distance. My acceleration due to gravity is negative 9.8. My time down is going to be 0.485 seconds squared. Do not forget to square this. My initial velocity is going to be 0. And then my time is 0.485. But it really doesn't matter because it's multiplied by 0. So that cancels out. All right, so if we do some of the math on this, 0.5 times negative 4.9. Actually, let's do order operations. Let's do the time squared first. 0.485 squared is going to give me 0.235. And then negative 9.8 times 1/2 is going to be negative 4.9. I multiply those two together. And I'm going to get a delta x, a change in position of negative 1.15 meters. Right. So it looks like, so why do I have a negative right here? Well, because I'm just solving for my time down, and I went in the negative direction. If you really want to answer how high did I jump, it would be best to just say, oh, well, in general, he just jumped 1.15 meters. Would be my final answer. Now, one thing you might be wondering is like, well, before, once we found the answer, we had to multiply it by 2 before, right, in order to find the hang time. We don't need to do that because we already applied our physics concept. We just didn't do it at the end. We did it at the beginning, right? Like I knew that my hang time was 0.97 seconds, and I knew that I had to only solve for the time down. So I divided my hang time by 2 to get 0.485 seconds. And then I'm just able to solve. So I used my physics concepts about hang time early on in this problem. And then I got my vertical right here, 1.15 meters. That is not actually how high I can jump. All right. So then now I have this value. What is my initial jump velocity at this point? So I have in terms of my givens, well, I need to decide what am I going to solve for? Am I going to solve for my time up or my time down? Honestly, you could actually solve for either one of these. And let's say since it's my initial jump velocity, I'm just going to do the time up. So time up. And let's look at my givens here. If I'm solving for my time up right here, well then my initial velocity is, well, I don't know that. That's what I'm looking for, right? My initial jump velocity. I'm not crossing that out, I'm underlining it. But I do know my final velocity. Right at the apex, that's 0 meters per second. And I know my acceleration due to gravity, that's negative 9.8 meters per second. And I also know my time up. Right? My time up is going to be the same as my time down, 0.485 seconds. And then when we add these two values up, we get that total hang time. But I can only solve one type of motion at a time, and so I have to just use half the hang time right here. So the equation, if I am given these variables that has final velocity and all these other ones in it, is going to be delta v, or not just final velocity is equal to my initial velocity plus acceleration times time. And my final velocity is 0. I'm looking for my initial velocity, negative 9.8, my time, 0.485 seconds. So 0.485 times negative 9.8 is going to be negative, I guess I just do subtracting right there, negative 4.753. But I just need to add that to the other side. So my initial jump velocity ends up being 4.753 meters per second going upwards. All right, and that's all there is to it. Thanks for watching it.